Thank you. And thank you for that very nice introduction. I'm honored to be here. Thank you for the invitation to come here and speak. And I agree with you that we work on some of the same issues. And it is a global responsibility for both for the governments, but also for us. And I'll talk more about that. So, do you hear me well standing? Or okay, stand like this. So I will talk about climate change and the science behind the headlines. And as we have seen, environmental issues are on the agenda, and it's becoming more and more so. And especially we have seen this last year, the global youth, the school strike that Greta Thunberg started kind of a global movement, even though it was there before her. And following up on the last question in the last session, I think, my personal view on that, Greta Thunberg is 16 years old, and thinking back when I was a kid in the 80s, I was also scared of nuclear war, and I was scared of the ozone layer and the hole in the ozone layer. But it didn't. My parents and all other adults didn't say that, oh, we shouldn't talk about this. You're only children. We talked about it, and then I wanted to learn more and find out about how the world works. And I think it's important for that to take this generation, the next generation, also serious in this, and not. I've seen some really bad discussions on this in Norway, also in the comment field that grown-up adults, they attack youth and children and youth that are engaged in climate and environmental issues, and I hope we will have a better discussion on this. So I will, in this talk, I will give you a brief introduction to climate and what is climate and how is it changing? Because, what we know is that the climate is changing rapidly. And it's mainly due to our usage of coal and oil and gas. And I put this keep calm and check the facts. So we will now keep calm and check the facts. But maybe once we have the facts, we will not longer keep calm. But I'll start with what is climate change? What is climate? How is it changing? And why is it changing? And also, why is this important and how does it affect us? And then finally, what will happen in the future? So first, weather and climate. So weather is not the climate, but it is a bit confusing to, I get a lot of questions on this. So you can think about weather as a snapshot of the atmosphere. It's what you see when you look out of the window today. And the meteorologist would then measure the temperature and the precipitation one day at a time, and that will be the weather that day. But what is then climate? So climate is then the long-term variability of the weather, taking for a longer period of time. So you can say something about the average weather. So then you don't only have you have the temperature and precipitation for that day. You also have for many other days. And this we measure the temperatures and the precipitation and a lot of other climate variables. Over maybe a period of 20 years, you will have an idea what the climate is. So when we talk about climate, we talk about a 20, 30-year average of the weather in a specific location. And that's also important to keep in mind because the climate is different and it varies everywhere. And you can see here, for instance, you see the cyclones coming over the Indian. You see for southern Africa, it's very different from the Sahara regions where you have high pressure systems and also more cloudy regions up in the Arctic. So it's also important to keep in mind that, for instance, the climate in Moscow is very different from the climate in Miami. So here you see The red colors are the average temperatures during the year. And you see with the higher summer temperatures and the lower winter temperatures in Moscow. This is further north and more inland than in Miami, where you have not so large variability between summer and winter. And also the precipitation varies a lot, where you have more dry conditions in Moscow, but in Miami you have these tropical cyclones coming in summer and late autumn. So this is also important to keep in mind. But what we see is that the temperature is increasing globally. And here you have the global average of the temperature. And you see especially this green line. So here, if this works, you see since the 1970s and up, it has been a really steep increase. And this has then got a lot of attention, and this is not something that we can explain by natural variability. And we can see this is the global average of the temperature increase. So here, but you can also look at this in a global map. So I'm going to show you a video, and you can see the years here. And you see this is just deviations from normal. So blue is colder than normal, and more yellow, red is warmer than normal. And you see it doesn't change that much. But now when we start going into the 70s and the 80s, you will see that something is changing. I'll see now that's the last 5 years. And you see really a big trend. And this is what we talk about when we talk about 1 degree global warming. It's the average number of the entire globe. But you see that there are areas that are warmer than this. So this is the average of the entire land areas and the vast oceans. You can see that the land areas, and you see also the vast Russian territory, it has a much larger, it has almost 2 degree warming. And also the Arctic areas, it's much warmer than 1 degree average. So how do we know this? So how we work is that we monitor the atmosphere. We monitor the atmosphere with satellites and with weather balloons. So you have stations, they have weather balloons sending up actually simultaneously 12 each day. So you can imagine all these balloons going up in the atmosphere. We also monitor the oceans, also the temperatures down in the oceans. And we also go further back in time, and then we we use whatever we can get that has some information. For instance, coral reefs and tree rings. And also you have this ice cores that you go deep into the ice and you look at the air bubbles in the ice to say something about the temperatures and also the CO2 content. So by using all this, we can see that the climate is changing. So this is our current climate. This is just an illustration. But so here is the current climate, but we are now, you can say that we are approached a new climate. But you see that the variability is high. And maybe this is one of the reasons why it's hard to grasp that the climate has changed already, because the variability is so high. So you can still have days that are very normal to the old climate. Like for instance in Norway, where I live in Oslo, last year we had a really nice winter, cold, crisp winter days. We could go skiing, a lot of snow. And you will still have days like this, even though the cold days are getting fewer and the snow is melting and the snow days are diminishing. So, but you will still have some of these days, even though they are fewer, because we go into a new climate with warmer temperatures. So why are the climate changing? I already said that it's mainly due to our usage of coal and oil and gas, and I'll say a little bit more about that. So in 1958, there was a guy named Keeling, pictured here, and he wanted to study the seasonal variability of CO2 in the atmosphere. So he wanted to study how plants breathe oxygen and CO2 and how this works out. So he put up a station in Hawaii. That was the most remote place he could put the station. And then he started to measuring CO2. But what he saw after some years was that there was a trend it wasn't only a seasonal cycle, there was a trend in the CO2 concentration. So he decided to let the station be there to get a longer time series. And here is the time series from Hawaii. Now we have also stations everywhere on Earth. But you see, when he started in 1958, so here, the CO2 concentrations were about 310 parts per million. So this is CO2 concentrations per million air molecules. And then it has been steadily rising ever since. And today we are over 410 parts per million. And this is a large increase. You can see from Elvis to Bieber, we had over 100 parts per million increase in CO2 concentrations. But what about before 1958? How was the CO2 concentrations then? And then we can go further back in time, so 800,000 years to the ice ages. And then we have to look into these ice cores again to look at the air bubbles in the ice. And then we can get the picture of how the CO2 concentrations looks like. And this, you see here so 0 is today, and then going back 800,000 years. And you see the concentrations, they have been varying with the ice ages. So right now, today, we are in a period between the ice ages. And this was the last ice age, where we had like a kilometer with thick ice extending from the North Pole and down. And then the CO2 concentrations were less because it follows the temperature. Another point here is that the CO2 follows the temperature, but during the last ice age, with that much ice, we only had 4 degrees colder temperatures than now. 4 degrees. So this 1 degree warming that we talk about now is huge because the climate is very stable in terms of temperatures in the long run. Another point I want to make here, if you look at today, and this is not just part of the figure, the frame of the figure, this is the CO2 concentrations today. So you can see that this is unprecedented for this many years. We have never seen this high and steep rise of CO2 concentrations as we have today. It's really a very rapid change. So why is the CO2 concentrations important then? And it's important because we are changing the whole greenhouse effect of the atmosphere. So the greenhouse effect, you might have learned this in school. It's the incoming solar radiation that the Earth receives, and it then sends out long-wave radiation, so thermal radiation. And then we have some gases in the atmosphere that absorbs this radiation and makes it comfortable here on Earth. Without the greenhouse effect, it would be 33 degrees colder. So we want the greenhouse effect. You can think of the greenhouse effect as putting on some clothes, extra clothes, when you freeze, because your body will radiate heat and you will get warmer. So you have all these different clothes and all these different greenhouse gases in the atmosphere. So you have water vapor, you have also some ozone, methane, but most importantly, you have CO2. But what we have done is that we have kind of put out an extra coat on top of this, on top of the greenhouse effect that we already have. And this extra energy is then warming the system. And then a lot of different effects have already happened. So this extra warming is then, you can say it's contributed by us, humans, and different factors contributing to this, but most important is because of our energy supply. So we are using oil and coal and gas. And this is to be transported by cars, also by airplanes, and we are also changing the land. So we are cutting down forests for farming, and we have also like this cattle and the way we eat and use the earth. So why is this change important? I guess maybe it's obvious, but we are changing the entire climate system by this increase in CO2 concentrations. So here are some examples. I won't go through all of them. I don't have time, but you can see we are increasing the temperature over both land and the oceans. We are decreasing, so this arrow shows the increase or decrease. We are decreasing the snow cover, decreasing the volume of our glaciers. We are increasing the air temperatures and the water vapor also, because the air can hold more water vapor when it's warm. We are decreasing the sea ice, and we are increasing the temperatures of the oceans also deep down. And now we see temperature increase 2,000 meters down in the oceans. And I think that we have already been able to change the ocean temperatures that much. I think that's pretty huge. So some examples, if we look at sea level, the sea level is rising, and it's rising 3.3 millimeters per year. It might seem like a small number, but if you think about that 71% of our globe is covered with oceans, it's pretty much a lot of sea level rise. And today, now we have a sea level rise of almost 25 centimeters higher. And this will continue to rise because it's a very slow process. This is not happening uniform over the entire globe. There are some places that have higher and some places are lower, but this is the global average again. And this can be really felt is when we have these storm surges in coastal areas, where you have a storm and the water is then rising with the storm, and it can then come a lot of water into the areas. For instance, the Sandy storm in New York some years ago, I don't know if you remember, but so I lived in New York for some years, and they still struggle with this Sandy storm, rebuilding everything that was destroyed back then. And so what happened was there came a storm. It became like a superstorm. The Americans are good at wording. So a superstorm that was coming into land, and even though that storm wasn't created by climate change, there's this much water, extra water outside New York that was then pushed into the city. And after economists, they actually put a number on how much extra water that came in New York and over Manhattan and everywhere else, and they put a number on it, and how much will that extra cost? I mean, you have some variability or some range here of this number, but it illustrates that there was some extra cost of climate change, and they asked who should pay, but that's a big question. Another example is the glaciers. So one of the biggest we have is the Greenland ice sheet, and it's melting, and the melting is accelerating. It's losing a lot of its mass every year. Now it's losing 286 gigaton. I mean, it's a very large number. It's hard to grasp, but just we can sum up, it's a lot. And this is also a process that will not stop right away. It's a slow process that will continue for a very long time. And this continues to sea level rise. And another example is snow cover. And we see that the snow cover is disappearing, especially during spring. So here's a map. You see the darker colors are negative. So we are losing the snow cover, especially in the northern areas. You see, for instance, also where I go ski a lot in the forest, the ski season is now 40 days less than it used to be. So this is measured by stations in the forest. And that's a lot. Of course, it's maybe not the most important climate change impact, but you see it has a huge effect on everything that is depending on the snow. And we are kind of changing the seasons in a way. And then the final thing I want to comment is the sea ice area. So this is a map showing the sea ice in the Arctic. And the yellow line here is what it used to be. So this is from 1991, 2000, that's the average. That's when we started to measure by satellites the sea ice extent. And then you see now how smaller it has gotten. And it's not only the extent, but also that the sea ice is getting thinner and younger. So it's a lot more fragile if there's a storm coming, for instance. And we expect the Arctic to be sea ice within maybe 20 years during this September, when it's the minima in the sea ice. Then I'm sure you remember the strong heat wave in 2010. And then it hit Russia really hard. And this is so climate change, one of the problems here are the local effects that we see, and this heat wave was very hot, of course, and it was very dry because it has been an early snow melt. And then also you had a blocking. So you had a strong blocking event that kind of put the air still, so the air pollution also stayed. And it killed thousands of people. And also a huge increase in forest fires. And you see in these pictures are people building like a ditch to prevent them from forest fires. And this event has been studied after by climate scientists to see if how normal kind of this event is, and they couldn't find similar for 500 years. So this was really something that you haven't seen. It's a very rare event. But they also concluded that heat waves like this will be more frequent and more intense and longer lasting in the future. And models show that this event might occur as often as 7 or 8 years, every 7 or 8 years by the end of our century. So also when we look at heat waves, it's important to see this is how the heat wave is more extreme, or it's increasing in Africa, on the African continent. And when we look at this impact, we also have to see where do people live. And here's to calculate the risk. And here you see how the population is expected to grow. And so it's expected that the African continent will get higher growth in exactly these areas that are already have troubles with heat waves. And this is just an example of climate risk. So we can calculate the hazard, we can calculate how the climate is changing, but then you also need to know about the population, about the exposure, and about the vulnerability of the population. How many people, are there a lot of old people? And when it comes to air pollution, how many people have asthma, allergies, and also heart diseases? So we need to collaborate, social scientists and natural scientists, to calculate this climate risk. And then my final part. So what will happen in the future? It's a $1 million question, I guess. So if we want to know the future, we have to look at, or we have to see what's happening today. And this is the growth in fossil energy consumption. And from the 1960s and up till today, and you see that it's dominated by oil, coal, and gas. You see some good news is that the renewables are increasing a lot, but still it's a long distance between the three big guys, the oil, coal, and gas. But we see that some of the coal production has been decreasing the last years, but we don't see the same in oil and gas. And then if we look at where these emissions come from, this is not to blame, but just to get the picture. You see here again the time, and this is the CO2 emissions. And you see the top emitters here. So the top emitter here now is China and US, and then all the EU countries and India. And you see this, I mean, what's happened in China and the economic growth that I guess no one was able to predict in the 2000s, and then this huge rapid increase, and then also that it has been flat the last years due to the more effective energy effectiveness. And then US slowly decreasing the last few years because they have been changing coal to gas mostly, and then also the same in EU. But then you also see that India is the emissions in India rising. And then here are the rest. But there are many ways to look at this. You can also look at fossil fuel per capita. And would you guess maybe which country is on the top then? Did I hear US? Yes. So then US is by far the greatest. If you look at per person, then you just split the emissions in the country per person, and you see it's 4 times almost the world average. But it is, you see here, the declining. But what I find is interesting here is that the Chinese emissions per capita is now the same as EU. And though it has a lot more people, so it says something about how high these emissions are. But there's also another way to look at this. What about before 1960s and the historical, I mean the cumulative emissions by country? And then you see US and EU has kind of the largest historical responsibility. And then you see China here, and also Russia, India, but these are the dominator. And this is why it's so hard to get a climate agreement, because who should pay and who should cut the most? This graph would suggest that it should be the EU countries and the US that should cut the most. And it is also responsibility in the Paris Agreement that I will talk about, that the rich countries should cut the most because they can and because they have more resources. So what will happen in the future? We don't know. That's one thing, because we don't know how much we are going to emit. So we don't know how the climate will be, but the climate will react to any of these paths. So this is the paths of future CO2 emissions. So we can make some storylines, and the gray ones here are baselines. So this is the historical emissions, and these are the baselines, possible futures if we follow just this path. We might then end up somewhere between 5 or 3 degrees global warming. But then these colored here are different aggressive mitigation scenarios if we are able to cut emissions. Now we'll talk more about, a little bit about these aggressive mitigations. But first, what we do know, that change will continue through this century and beyond. So we know that temperatures will continue to rise, and we know that we will change the precipitation patterns that we already have done. So the atmosphere can hold more water. It's taking more water from the ocean when it gets warmer. This changes the precipitation patterns. We already see in Norway it's raining 20% more than it used to, and especially these extreme precipitation events, the precipitation that comes within 1 hour or within 10 minutes. But a general pattern we see is that the wet areas are getting wetter and the dry areas are getting drier. And then we know that the sea level will rise somewhere between 0.4 and 1.2 meters by the end of our century. The reason for this number is that we don't know what the emissions of CO2 is going to be. Are we able to do a strong aggressive mitigation? Then we might just have 40 centimeters of global sea level rise. So, I mean, I can talk more about what we will experience. I can have one example. But we will see a change in the forest fires, drought, and also with species loss. That because we are changing the climate, we're also changing how animals behave, and we see that now. And also we can have a reduced food production, because a lot of these areas that are affected also have a lot of food production. It will affect the global food supply, and also for fisheries. And then we see the access to clean water is being threatened. An example here is heat waves. We see an increase in heat waves with global warming. So this is a study looking at the 1.5 degree world, a 2 degree world, and a 4 degree world. And 80 is the effective temperature. So this study combined temperature with relative humidity. So then, warm air combined with high humidity can be very dangerous. And I guess you've all been sitting in a sauna and you put on some water, and it doesn't increase the temperature, but it feels a lot warmer because you have this high humidity. And the same you see here, because you can't sweat when it's humid, so you can't cool yourself down as effective. So here you see effective temperatures of 40 degrees Celsius in a 1.5 degree world, and then it's just increasing for 2 degrees, and then 4 degrees. All these areas are affected. But what I find more concerning is the 55, so kind of like a super heat wave. here in these areas that are also areas that are highly populated. And this is really in danger for human life. So we really don't want this 4-degree world to happen. So what do we have to do then to avoid this 4-degree world to happen? And what is needed to stay well below 2 degrees that was in the Paris Agreement that was put into place in 2015. It will start in 2020. And here is the emissions that are needed. So you can see this is the rise that we have seen, and then we need this very sharp decline in emissions. Here you see 0, which means that we actually need negative emissions by the end of our century. And that means that we need some technology to capture CO2 from the air. So this is called carbon capture and storage, and then put the CO2 down in the earth. And this is something that it's been tested, but it's not something that we have in large scale at the moment. But it's needed if in these scenarios to keep well within 2 degrees. So there are solutions. I mean, what can we, I get these questions a lot, what can we do as individuals? And we are part of the solution especially when we think about what we eat and how we transport ourselves. So to try and take the train instead of going by airplane, but that might be very difficult. Even if you try, it might take a day instead of an hour. And then we need governments to come in to help us to choose a more environmentally friendly way to do so. And I want to end with this figure, which I think sums up a lot of our issues, and that is the World Overshoot Day. So the World Overshoot Day today was, this year, 2019, was 29th of July. This means that for 2 months now we have been using more resources than the Earth is able to regenerate. But this figure also shows it's very different from country to country. So they have made, so this shows here, what if we all lived in Qatar? What if the world population lived like in Qatar? The World Overshoot Day would be in February. And we still also can go down here. Norway is 8th of April, followed by Russia, 26th of April. And you can follow this all the way up here. There are a lot of countries that are not on this list, which means their emissions are very low. One thing that you can also do is to flip this figure. So climate change will be felt more in the countries that have the lowest emissions, and that makes climate change very unfair. A country like Bangladesh will be heavily more influenced by climate change or sea level rise than Netherlands, because the Netherlands have one of the world's greatest prevention system from flooding, but Bangladesh has not, and Bangladesh has almost no emissions of CO2. So to summarize, so climate change is a rapid warming of the atmosphere, and we cannot explain it by natural variability alone, and it's caused by our use of fossil fuels. And it's important because of the local effects that we feel. And we don't know what will happen in the future because it will depend on what we do, but there are solutions to this. We just have to put them in place. Okay, thank you.